I'm Anil Kumar, and in this video we will try to understand how composition of functions help us to solve real life situations. And in this particular video I'll take some trigonometric expressions to see how to formulate composition of functions and use trigonometry to solve questions. Now let us consider a case that there is a tall building and there is a fire on, let us say, the 10th floor of the building. So let's assume that this is the building for us, and in this particular case we have fire on the 10th floor of the building. Now you have to have an access to this building's 10th floor, but there is a restriction, and the restriction is that we have a garbage bin here, big garbage bin, and now that garbage bin is, let us say, the dimensions of this garbage bins are that the width is 2 and the height is 3. So that is a restriction. So you're kind of restricted, and you want to know what is the minimum length of ladder which can be used to reach the 10th floor. So that is the question for us. I hope you understand the question, right? So it's a real life situation. We are trying to figure out the minimum length of the ladder which can be placed to reach the building. So that is how the ladder could be, right? Since there is a garbage bin here whose dimensions is 2 by 3, so you cannot be so close, right? So, and that is probably the 10th floor for us. Let's say this is the 10th floor. Now the question is, what is the minimum length of the ladder which can be used in this situation to reach the 10th floor? Now how will you do this particular question? Now that is where we will introduce you both composition of functions and how to relate distance in trigonometric terms. Now when we have a situation like this, you can consider that this point here will be the point which is 2 units from the wall and 3 units higher on the wall, right? So what we have here is basically this height is 3 for us and this distance is 2 units. Let us say the angle which the ladder makes is theta. In that case, we can write the length of the ladder, so that is the length of the ladder. We can split this length into 2 parts. Let's say L1 as this part from the foot on the floor to point A and then to point B. So, and L2 be the length between A and B. Now if we use the trigonometric ratio, that is tan theta, sine theta, or cosine theta, we can find L1 and L2, right? So if you consider the triangle, let's say garbage bin point is P, this point is P for you, and let's call this point as Q, and let this be the origin. Okay, so there are too many dimensions here. Now how is the length L1 related with angle and the height of the garbage bin given to us? Since that is the opposite side and this is the hypotenuse, I can write sine theta as equals to 3 over L1, right? 3 over L1. Or length L1 of the ladder will be 3 over sine theta. Perfect. Now if I consider the other triangle, which is triangle AQB for me, in that case we know the side, adjacent side is 2. So in this case we can use cosine theta. The angle will be same for the ladder, correct? So now we can say cos theta is equals to 2 over L2, right? So L2 can be written as equals to 2 over cos theta, right? Now combining these two, we can get the length of the ladder in terms of the angle. So the length actually is equals to length L1 plus L2. So we get from here L1 is 3 over sine theta plus 2 over cosine theta. So that is how we can relate length of the ladder to the angle of inclination, right? Now, so now And theta we can very easily find, since we know that the height is 2 and this width is 3. So now in this kind of a situation, what we have done is that we have written L, the length of the ladder, as a function of theta, right? So you could write this as 1 over sine theta is cosecant theta. You could also write this as 3 cosecant theta plus 2 secant theta. Is it okay? So you could also express it in the reciprocal trigonometric ratios. Anyway, once you get a relation in one particular variable like this, you can always find maximum or minimum. In this case, we are interested in minimum length, the minimum length of the ladder using calculus or other techniques which you will soon learn, right? But the idea here is first to get an equation in one variable, and that is how we can get equation in one variable, and this time that happens to be the angle. And since it is angle involved, we have a trigonometric equation, right? So that is how we can use trigonometry to solve real life situation. Let me give you one more example. Okay, this time let me make a bigger figure. Okay, let's say we have a triangle formed by edges of two rods. Let's say this is one rod, which is, let us say, 15 centimeters. And then we have another rod, which is, let us say, 10 centimeter. Right? So let's say this is another rod, which is 10 centimeter. Now we are kind of rotating this rod, kind of like this. And we want to know, if we know the angle of rotation, what is the rate at which the area of the triangle is changing, let's say like that, right? So that means we are interested in area of the triangle. So we are interested in a function which relates area of the triangle with angle of rotation. So that is the concept. Now if you see, area of a triangle is what? Let me complete this triangle first. So let me join these two ends. Okay, so let's say we join these two ends. Then area of the triangle is given by half base into height, where height will be, let's say, h height, right? And let me write down theta as the angle. Okay, now what is the area of a triangle? So area of the triangle A is equals to half base times height. Now in this case we know what base is. Base is 15, right? So we have half times 15 into height. Now we need to write relation of area of this triangle in terms of the angle of rotation. How do we get that? So for that we can use trigonometric ratio. The height is always the altitude, right? So it forms a perpendicular. Now since we know, that becomes now the hypotenuse of this right angle triangle, right? Now in that case we are using the opposite side edge and the hypotenuse. So sine theta is the relation which connects them. So we can say sine theta equals to height over 10, right? And so that gives us that height is equals to 10 times sine theta, right? So we get a relation between height, which is dimension of the length, in terms of angle, correct? Now combining the two equations which we have now, one, the area is equals to half base into height, and two, what is theta equals to, right? So we're talking about composite functions, right? Earlier, equation number 1 for us is what? Let me write down equation number 1 as let me write area A as a function of height. Is it okay? As a function of height, it is half of 15 times height. And the other equation which we have here is relating theta, right? So that means we are relating height with theta. So height as a function of angle theta we have as equal to 10 sine theta. Now if we have a composite function, that is to say if we have a, and within brackets, instead of h, I put h of theta, then what do we get? You get the idea, right? So instead of h, I put h of theta. Then I have to replace h with the function h theta, right? So what we get here is half of 15 times h theta is 10 sine theta. So we can write this as 10 sine theta, right? And combining, we can really simplify this. So 2, when you divide into 10, you get 5. 5 times 15 is 75. So we get 75 sine theta. So we get such a simple relation which relates angle in terms of theta. That is composition of function which we are talking about. And see how important it is to understand how to write a function in terms of different variables. Then depending on the situation, we can solve our problems. But the first step always is to get the right equation in the variables we are interested in, right? I hope with this example you can now appreciate how composition of functions can be applied to trigonometric relations, and we'll further explore them in advanced functions and calculus. I hope that helps. Thank you and all the best.